Welcome back, everybody. In this video, we're going to continue with solving problems with radicals in them, but focus on a couple examples on word problems. So the first question we're going to do involves the Pythagorean theorem. So as a reminder, the Pythagorean theorem is valid when you have a right triangle. So that means your triangle has a 90-degree angle for one of the corners. And we typically abbreviate that or show that with a little square in that corner. Now, on that triangle, you have two legs, A and B, and then the side that is across from that 90 degrees is usually labeled as C and is called your hypotenuse. It is also, by the way, the longest of the three sides. So if you have numbers and you're like, I'm not sure which is which, the longest side is always the hypotenuse in a right triangle. Now, the Pythagorean theorem says the following. It says that if you square A and B and add them together, that would equal to C squared. And this is a formula that we use all the time for applications. So here's an example. We're going to find the length of the unknown leg of the following right triangle. So notice that you have 4 meters here, B, and 10 meters. Again, what's across from the 90 degrees is always the hypotenuse. That's the one you need to make sure you recognize. So this is your C right here, whatever is across from that 90 degrees. So that's the one I really need to know. A and B, it doesn't really matter which leg you call A or B, but the hypotenuse is the key one. So I'm going to use our formula here. So that would be 4 squared plus B squared is equal to 10 squared. Oops, 10 squared. Now 4 squared is 16 and 10 squared is 100. So I'm going to just start by simplifying. I'm also going to subtract the 16 to both sides. And I have B squared is, let's see, equal to 84 here. Now at this point, there's different ways that you can solve something like this, but one of the easiest ways to do it is to just take the square root of both sides here. So here we're kind of using the square root idea after the fact. So if I take the square root of B squared, it would cancel out. So we're kind of using the reverse process. And I do the same thing on the other side. Technically, when you take the square root of both sides, we do use plus or minus, but it wouldn't make sense to have a negative answer here because we're talking about lengths of a triangle. So we'll just use the plus version. So B is equal to the square root of 84. Now, what you'd want to do is you'd want to think about your factor pairs here. One factor pair would be 4 times 21. And the reason I like that one is because it has a perfect square in it. So I'm able to go ahead and do that to break down this radical a little bit more. Square root of 4 is 2, and I can get 2 root 21 as my final length here. So B would be equal to 2 root 21, and that is in meters. And of course, you could always use your calculator if you wanted to approximate this. It is about 9.2 meters if you want to check that at home. When you're doing your calculator, you would do 2 times the square root of 21. So there's always a hidden multiplication symbol in between if you don't see it. So a little bit different idea with the radicals, kind of using it after the fact to help cancel out that square. In our next example, we have the following. So a 50-foot supporting wire is to be attached to a 75-foot antenna, and this wire will be anchored 20 feet from the base of the antenna to the ground. So this is my very rudimentary picture, but let's say you have some sort of antenna going up into the sky. We're going to attach a wire to it here and then also here on the ground to help support it. And what we know is that the total of the antenna is 75 feet. I know the wire is 50 feet long, and I know that it's going to be attached 20 feet away from the antenna on the ground. So my first question is, how high from the base of the antenna is the wire attached? Now, you're not going to attach it at the very top necessarily, right? So it doesn't have to attach at the top. It could attach farther down. So we're not assuming that it attaches at the top at 75 feet. What we're going to do is we're going to use the Pythagorean theorem we could do here to actually figure out what that's going to be. So we're looking for this, which is the length there of how high it should be. So let's do A first. So using the Pythagorean theorem again, now think about this. Where is your right triangle? Well, you would have that right triangle right here at the bottom, right? That's where it would make sense. So across from that right triangle, that would be your C. So our hypotenuse here is the 50. So I would know that one of my legs is 20, the other is X, and then the other side is 50. Now 20 squared is 400. And let's see, 50 squared is 2,500. If I subtract the 400 from both sides, I have X squared equals 2,100. Now, again, we're going to use square roots here in a little bit different way. We're going to use it to cancel out the square. So I'm going to take the square root of both sides. Again, technically, whenever we do square roots, there is a positive and negative square root that could result. Here, a negative doesn't make sense because we can't have a negative height. So I'm just going to use the positive height. And I have the square root of 2,100. Now, 2,100 does break down into 21 times 100. And I like 100 because it's a perfect square. So this is root 100 times root 21. Root 100 becomes 10. So the exact height there that is attached at would be 10 times root 21. And this is in feet. Now, again, this is one that you probably want to put into your calculator. And if you do, you get about 45.8 feet. So it's about almost 46 feet above the ground is where we would attach it. So it's not all the way up to the top, right? There's a little bit of space there where it gets attached. Our second question says, local regulations require that a supporting wire be attached at a height no less than 3/5 of the total height of the antenna. So it can't be too low. It has to be high enough. So it has to be at least 3/5 high compared to the total length of the antenna. Based on part A, have local regulations been met? Well, the first thing I need to do is I need to figure out, well, what is 3/5 of the antenna? And the antenna was 75 feet altogether. And if you do this and you multiply it out, you do get 45 as your final result here. So 3/5 would be 45 feet, excuse me. Now notice that we're placing our antenna at 45.8 feet high. So we're good. We are above that 3/5 mark, right? Just barely, but we're going to make it. We're just above that 3/5 mark. So we do meet the local regulations. So our local regulations are actually met. Good. And if not, we'd have to go back and change it and either change the position of something or perhaps get a longer wire to make it work. All right, and one last example here. Again, all of these really use the Pythagorean theorem. It says the current route of a race, let's say, runs along the perimeter of a grassy shape that resembles a rectangle. So maybe there's a race going on or people are working out and they like to run, around this grassy area. So it's approximately rectangular in shape. So one of the main sides is 80 meters and the other is 100 meters. How far would someone have to travel if they cut across diagonally from one corner to another? So perhaps, let's say someone was running the race and maybe they decided, okay, they're all done. They really don't want to finish this. They just want to go back, to their car and they're not going to complete the race. Well, maybe they want to cut across the line and finish. Or maybe I'm a spectator and I was waiting here to see my friend run by and now I want to book it to the finish line or something like that. So we want to know really what is that diagonal? So that is what we're looking for here. That's our X. Now, if this was a rectangular shape, this would be my 90 degrees. So in this case, our hypotenuse ends up being our variable. So a little bit different here compared to the others. So let's go ahead and use our Pythagorean theorem. One of my legs is 80. The other is 100. And in this particular case, I'm solving for the hypotenuse, which is, again, right across from that diagonal. Now, 80 squared is going to be 6,400. 100 squared is going to be 10,000. I'm going to add these together and I get 16,400. Again, I'm going to take the square root of both sides. Technically, it is plus or minus, but we're not going to need the negative here because it doesn't make sense to have a negative length. So that side is going to be the square root of 16,400. Now, you're going to have a lot of different factor pairs you can try here, but there is one factor pair that is 400 times 41, and 400 is actually a perfect square. The square root of 400 is 20, so this becomes 20 root 41. And let's see, we were in meters here. And if you use your calculator on this one, you should get about 128.1 meters. So if someone wanted to cut across diagonally, it would be a little over 128 meters, which would definitely save you some time, right? Because if you were to walk this way first, that's 100 and then another 80. So you'd have to go 180 meters, but the diagonal would, again, theoretically get you there faster if you didn't want to complete the full rectangle all the way around. All right, so just to wrap it up, I'm just going to fix my title a little bit. So I guess I should maybe tell this more, solving more problems that use radicals rather than contain it. So you don't have a radical at the beginning of these word problems, but we use them at the very end to help us solve. And again, for this particular video, the big application here was the Pythagorean theorem. So that is a really popular application in geometry whenever you have right triangles.